Bismillahirrahmanirrahim. I am Dr. Ayaz Afsa, and our topic today is sampling part 2. In this part, we'll discuss different types of sampling and different types of sampling. But before we move on, I would like to draw your attention to our previous lecture where we ended, that was on standard error of sample and how it is calculated. So if there are many samples and they are taken from the same population, it is unlikely that they will have characteristics identical with each other or with the population. Their means will be different. Sampling error is the difference. What is sampling error? The sampling error is the difference between the sample mean and the population mean due to the chance selection of individuals. Sampling error reduces as the sample size increases. If you have a bigger sample size, then the error of sampling will be minimized. If the samples of less than 25 usually yield a normal sampling distribution of the mean. How do we calculate a standard error of sample? So it is calculated in the following way. At stage number 1, draw several number of samples of equal size from a population to create a sampling distribution. And at stage number 2, calculate the standard error, that is SE, of the mean. And that would be in the form SE is the standard error is equivalent to SDS, standard deviation of the samples, divided by under root of the number in the sample. It seems to be a bit mathematical formula, but it's very simple. The standard error is equivalent to the standard deviations of the samples, and it is divided by the under root of the number in the sample. With the standard error, we have the standard error of proportions as well. As I said earlier, that one answer to how big a sample must I obtain is actually how accurate do I want my results to be. And this is will be illustrated in the following example. Well, how big our sample could be? It depends on how accurate we want our results to be. Look at this example. A school principal finds that the 25 students she talks to at random are reasonably in favor of a proposed change in the lunch break hours. 66% being in favor and 34% being against. How can she be sure that these proportions are truly representative of the whole school, which has 1,000 students? So what is being suggested here generally is that in order to overcome problems of sampling error, in order to ensure that one can separate random effects and variation from non-random effects, and in order for the power of a statistics to be felt, so one should opt for as large a sample as possible. A simple calculation of the standard error of proportions provides the principal with her answer. What she can do, the standard error is equivalent to P multiplied by Q. P multiplied by Q, actually that was under root and divided by N. I couldn't put over here. Where P, the percentage in favor, and in this case there were 25 students and 66 were in favor, 34 were against. So the formula would be P is the percentage in favor, that is 66, multiplied by Q, that is 100% minus P, that is 66 here, and that is divided by the sample size. This formula assumes that each sample is drawn on a simple random basis. A small correction factor called the finite population correction or FPC, finite population correction, is generally applied as follows. With a sample of 25, the standard error would be 9.4. In other words, if we take the favorite or a favorable vote, can vary between 56.6% and 75.4%. Likewise, the unfavorable vote can vary between 43.4% and 24.6%. Clearly, a voting possibility ranging from 56.6% in favor to 43.4% against is less decisive than 66% as opposed to 34%. What these numbers show, 66% were in favor in the principal's case and 34 were against that one. If she takes, 100 students, then the standard error becomes 4.5 and the variation in the range is reduced to 61.5% to 70.5% in favor and 38.5% to 29.5% against. So sampling the whole school's opinion, that is the total number of students, that is 1000, reduces to the standard error to 1.5 and the range is to 64.5% to 67.5% in favor and 35.5% to 32.5% against. It is easy to see why political opinion surveys are often based upon sample sizes of 1000 to 1500. So what is being suggested here generally is that in order to overcome problems of sampling error, in order to ensure that one can separate random effects and variation from non-random effects, and in order for the power of a statistics to be felt, one should opt for as large a sample as possible. As Gorard in his work 2003 says, power is an estimate of the ability of the test you are using to separate the effect size from random variation, and a large sample helps the researcher to achieve statistical power. Samples of fewer than 30 are dangerously small as they allow the possibility of considerable standard error, and for over around 80 cases, any increase to the sample size have little effect on the standard error. Our next topic will be about the representative of the sample. How to make your sample representative of the total population. The researcher will need to consider the extent to which it is important that the sample in fact represents the whole population in question. In the example above, the 1,000 students, if it is to be a valid sample, the researcher will need to be clear what it is that is being represented, that is, to set the parameter characteristics of the wider population, the sampling frame, and set the parameter characteristics very clearly and correctly. There is a popular example of how poor sampling may be, unrepresentative and unhelpful for a researcher. Let's take an example. A national newspaper reports that 1 person in every 2 suffers from backache. This headline stirs alarm in every doctor's surgery throughout the land. However, the newspaper fails to make clear the parameters of the study which gave rise to the headline. It turns out that the research took place in a dim part of the country where the incidence of bad backache might be expected to be higher than elsewhere. In a part of the country which contained a disproportionate number of elderly people, again who might be expected to have more backaches than a younger population, in an area of heavy industry where the working population might be expected to have more backache than in an area of lighter industry or service industries, and use only 2 doctors' records, overlooking the fact that many backache sufferers went to those doctors' surgeries because the 2 doctors concerned were known to be overly sympathetic to backache sufferers rather than responsibility suspicious. These 4 variables, that is of climate, age group, occupation, and reported incidence, were seen to exert a disproportionate effect on the study. That is, if the study were to have been carried out in an area where the climate, age group, occupation, and reporting were to have been different, then the results might have been different. So the newspaper report sensationally generalized beyond the parameters of the data, thereby overlooking the limited representativeness of the study. It is important to consider adjusting the weightings of subgroups in the sample once the data have been collected. For example, in a secondary school where half of the students are male and half are female, consider pupils' responses to the question, how far does your liking of the form teacher affect your attitude to work? So if you look at the variable, it is how far does your liking of the form teacher affect your attitude to schoolwork, and we have the respondents male and female in the right hand column, and in the horizontal row there are the options: very little, a little, somewhat, quite a lot, a very great deal. So look at the responses. In the male, very little is 10, female 50, and total is 60. A little, male 20, female 80, total 100. Somewhat, male 30, female 30, total 60. Quite a lot, male 25, female 25, total 50. And a very great deal, male 15, female 15, and total 30. Let's say that we are interested in the attitudes according to the gender of the respondents, as well as the overall results. In this example, one could surmise that generally the results indicate that the liking of the form teacher has only a small to moderate effect on the student's attitude to work. Look it again. However, we have to observe that twice as many girls as boys are included in the sample, and this is an unfair representation of the population of the school, which comprises 50% girls and 50% boys. That is, girls are overrepresented and boys are underrepresented. If one generalizes the two sets of scores by gender to be closer to the school population, either by doubling the number of boys or halving the number of girls, then the results look very different. Now look how the result would be different in this slide. The same question: how far does your liking of the form teacher affect your attitude to schoolwork? So very little is 20, male. Answer: female is 50, total 70. A little, 40 male, 80 female, 120. Somewhat 60 male here, 30 female, total is 90. And quite a lot, 50 for the male, female 25, 75 total. A very great deal, 30 and 15 and 45. If you compare this with the first one, there was 15 and 50, 30, 25 and 50, and now you have 30 from the male and 50 from the male over here. In this latter case, a much more positive picture is painted, indicating that the students regard their liking of the form teacher as a quite important feature in their attitude to school work. Here, equalizing the sample to represent more fairly the population by weighting yields a different picture. Weighting the results is an important consideration. That was about the representation of a sample, and how can we make or think about making any sample representative. There would be more later on, but this time let's move to discuss whether what are the problems in accessing the sample. How to reach the sample, is that a problem? Or is it easy to get a sample? Well, access to a sample is a key issue and is an early factor that must be decided in research. Researcher will need to ensure that access is not only permitted but also in fact practicable. Whether you will be able to reach the sample, those people, or you won't. I'll give you an example to understand this phenomena. Take an example, if a researcher were to conduct research into truancy and unauthorized absence from school and decided to interview a sample of truants. The research might never commence, as the truants by definition and meaning would not be present. Similarly, access to sensitive areas might be not only difficult but also problematic, both legally and administratively. For example, access to child abuse victims, child abusers, disaffected students, drug addicts, school refusers, bullies, victims of bullying. So there will be many issues related with that one, and people create many hurdles to reach the sample and the people. In some sensitive areas, access to a sample might be denied by the potential sample participants themselves. For example, AIDS counselors might be so seriously distressed by their work that they simply cannot face discussing with the researcher the subject matter of their traumatic work. It is distressing. It is distressing enough to do the job without living through it again with a researcher. So there are a huge number of issues related with access to the sample. Access might also be denied by potential sample participants themselves for very practical reasons. For example, a doctor or a teacher simply might not have the time to spend with the researcher. Further, access might be denied by people who have something to protest, something to protect. For example, a school which has recently received a very poor inspection result, or poor results on external examinations, are people who have made an important discovery or a new invention and who do not wish to disclose the secret of their success. The trade in intellectual property has rendered this a live issue for many researchers. So there are many reasons that might prevent an access to the sample, and researchers cannot afford to neglect this potential source of difficulty in planning research. In many cases, access is guarded by gatekeepers. And by gatekeepers mean people who can control researchers' access to those whom they really want to target. For school staff, this might be, for example, head teachers, school governors, school secretaries, form teachers. For pupils, this might be friends, gang members, parents, social workers, and so on. So it is critical for researchers to consider not only whether access is possible, but also how access will be undertaken. To whom does one have to go, both formally and informally, to gain access to the target group? So not only might access be difficult, but also its corollary, release of information, might be problematic as well. For example, a researcher might gain access to a wealth of sensitive information and appropriate people, but there might be a restriction on the release of the data collection. In the field of education and if we take the example of the United Kingdom, reports have often been known to be suppressed, delayed, or doctored. It is not always enough to be able to get to the sample. The problem might be to get the information out to the wider public, particularly if it could be critical of powerful people. So these were some of the issues, and there might be many related with this one, where access to the sample is not an easy task, and while designing the research plan, a researcher must keep in mind and consider whether the access to the sample would be easy or not. Now, let's have something to discuss about the sampling strategies. What are the sampling strategies which can be used in research? How do you, in simple words, how do you make samples? So in research literature on sampling identifies two main methods of sampling, two main categories of sampling. And the researcher must decide whether to opt for one of them. So one is a probability, also known as a random sample, or a non-probability, also known as a purposive sample. So we'll discuss them one by one, and their different forms. Okay, the difference between probability and non-probability sample is this. In a probability sample, the chances of members of the wider population being selected for the sample are known. Whereas non-probability sample, the chances of members of the wider population being selected for the sample are unknown. In the former, the probability sample, every member of the wider population has an equal chance of being included in the sample. Inclusion or exclusion from the sample is a matter of chance and nothing else. In the latter, non-probability sample, some members of the wider population definitely will be excluded and others definitely included. That is, every member of the wider population does not have an equal chance of being included in the sample. So let's look at the first one, probability sample. Probability sample, in this latter type, the research has deliberately or purposely selected a particular section of the wider population to include in or exclude from the sample. So a probability sample, because it draws randomly from the wider population, will be useful if the researcher wishes to be able to make generalizations, because it seeks representativeness of the wider population. Probability sampling is popular in randomized controlled trials. On the other hand, a non-probability sample deliberately avoids representing the wider population. It seeks only to represent a particular group, a particular named section of the wider population, such as a class of students, a group of students who are taking a particular examination, a group of teachers. A probability sample will have less risk of bias than a non-probability sample, whereas by contrast, a non-probability sample, being unrepresentative of the whole population, may demonstrate some kind of skewness or biasness. Probability sample, look at some of the examples. Well, in the diagram on the left, if you play, you see the dice, and it has numbers, you see, on each side, and it has 6 sides, and when you throw it, there are equal chances of any side to appear. In another sample, on the right, you see it's about male and female. So there are equal chances, half of the chances for male and half for the female. So when the probability, it is a probability sample when the chances of getting are equal to everyone. So every member of the population can get into the sample. So every member of the wider population has an equal chance to be included, and choice is made on chance alone. The aim is for generalizability and wider representation of the sample. As compared to random probability sample, we have a simple random sampling. So there are several types of probability samples, and simple, what are they? For example, simple random samples, systematic samples, stratified samples, cluster samples, stage samples, and multi-phase samples. They all have a measure of randomness built into them, and therefore have a degree of generalizability. In simple random sampling, each member of the population under study has an equal chance of being selected, and the probability of a member of the population being selected is unaffected by the selection of other members of the population. That is, each selection is entirely independent of the next. The method involves selecting at random from a list of the population a sampling frame. So the method involves selecting at random from a list of the population the required number of subjects for the sample. This can be done by drawing names out of a container until the required number is reached, or by using a table of random numbers set out in matrix form and allocating these random numbers to participants or cases. So because of probability and chance, the sample should contain subjects with characteristics similar to the population as a whole. Some old, some young, some tall, some short, some fit, some unfit, some rich, some poor, etc. However, one problem associated with this particular sampling method is that a complete list of the population is needed, and this is not always readily available. Example of random sample. You can look at this. Drawing randomly from a list of population. For example, names from a hat are using a matrix of random numbers. Next is systemic sampling. And this method is a modified form of simple random sampling. It involves selecting subjects from a population list in a systematic rather than a random fashion. For example, if from a population of say 2000 a sample of 100 is required, then every 20th person can be selected. The starting point for selection is chosen at random. One can decide how frequently to make systematic sampling by a simple statistic. The total number of the wider population being represented divided by the sample size required. Systematic sampling. So every nth person, for example, every fourth person, so n stands for any number. To find the frequency, use the formula that f is equal to n over Sn, where f shows the frequency interval and where is capital N shows the total number of the wider population, and Sn is the required number in the sample. Let's say that the researcher is working with a school of 1,400 students. So by looking at the table of sample size, look at this, it is usually provided in the books and also on the net. Let's say that the researcher is working with a school of 1,400 students. By looking at the table of sample size required for a random sample of these 1,400 students, we see that 301 students are required to be in the sample. How? So look at these are, we discussed, you see in the previous lecture as well, this table. If you have a 30, number is 30, that much would be required at 3 levels of certainty. If you have a 90% confidence, these are the figures, that is 95%, and it is also 99%. And this is the number, and look what we are looking for, 1,400. It comes over here. So if your population is 1,400, this would be the result with a 90%. This is the level of the confidence at 90%, 95%, and 99%. In another table, it also gives, you see, not only the confidence level, but also the sample size, and I think I missed that table here. Well, if you look at some standardized table, it will tell you that if it is 1,400 is the total population, the required number would be, for the sample, should be 301. And if you divide, you see, the total number with the sample, you will get 4.6. It means you can round it to 5. Hence, the researcher would pick out every 5th name on the list of cases from the box. Such a process, of course, assumes that the names on the list themselves have been listed in a random order. a list of females and males might list all the females first before listing all the males. If there were 200 females on the list, the researcher might have reached the desired sample size before reaching that stage of the list which contained males, so thereby distorting or skewing the sample. So this is problem with this one. So make sure that it is a representative of the male and female together. Another example might be where the researcher decides to select every 30th person identified from a list of school students. But it happens that, number one, the school has just over 30 students in each class, and number two, each class is listed from high ability to low ability students, and number three, the school listing identifies the students by class. In this scenario, although the sample is drawn from each class, it is not fairly representing the whole class population, since it is drawing almost exclusively on the lower ability students. So this is the issue of periodicity, the issue of periodicity mentioned by Colon in his work in 1979. Not only there the question of the order in which names are listed in systematic sampling, but also there is the issue that this process may violate one of the fundamental premises of probability sampling, namely that every person has an equal chance of being included in the sample. But that was about the probability and systematic sampling. Now look at another type of sampling that is called stratified sampling. In stratified sampling, it involves dividing the population into homogeneous groups. Makeup and the characteristic features are the same. So each group containing subjects with similar characteristics is called homogeneous group. For example, group A might contain males and group B females. In order to obtain a sample representative of the whole population in terms of gender, a random selection of subjects from group A and group B must be taken. If needed, the exact proportion of males to females in the whole population can be reflected in the sample. The researcher will have to identify those characteristics of the wider population which must be included in the sample. That is, to identify the parameters of the wider population. So to organize a stratified random sample is a simple two-stage process. First, identify those characteristics that appear in the wider population that must also appear in the sample. That is, divide the wider population into homogeneous and, if possible, discrete groups, discrete means strata. For example, males and females. And at the second stage, randomly sample within these groups, the size of each group being determined either by either by the judgment of the researcher or by reference table, as I showed you in the previous slide. Example of a problem, a stratified sampling. There are certain problems, and what are those problems in stratified sampling? Well, there is a problem of strata, or groups or subgroups within a bigger group. Strata means subsets or subgroups. The greater the number of strata, I mean if there are more variation in the population, and there are different strata or groups within it, or different sets within it, then you require the larger the sample will be. Therefore, keep to as few strata as necessary, means the number of people, then their diversity should be minimum. If there are very divergent people in the group, you need a larger sample accordingly. Look at this. These are the schooling, and you have the subtotal and sample size required. So no schooling, and pre-primary and primary incomplete and primary complete and junior secondary and senior secondary and tertiary non-degree and tertiary degree. So if you have so many groups within it, you need a huge, a bigger number, and within each there would be a subtotal of these, and the sample size you require. Look, if the sample, no schooling, their total number is 35,000, you calculate it. So what would be the sample size for this number, 35,000? Well, sample size required is 380 from here, and pre-primary 6,811 subtotal hai. Then you need sample size 364, and that leads total without strata would be 384, and within each you need that sample size with this number. So what are the problems of strata? So you have a whole company or a population, and the number is, say, 1,000 total wider population. The sample you would be required would be 278. If it is homogeneous, then total would be the same, 278. But if you don't have a homogeneous group, and you also take into account different strata or subsets or groups within the population, and you come to English employees 800 and Scottish employees 100 and Welsh 50 and American 50, so you have to calculate for each. Say English 800, the sample required would be 260. That is the n total number, this is sample. And for 100 Scottish, you need 80 number in your sample. And for Welsh 50, we have 44, and American 50 and 44. And then you get, you see, the total for this company would be 428. So it has actually increased. You see the difference? When the total you take as homogeneous group, it is 278. When you take, you see, divergent group and subclassification and strata within the group, your number dramatically increases. Now 278, it is almost the double of it. 428 would be the requirement. So random stratified sample, there are 3 stages of making sample. First stage is identify those characteristics which appear in the wider population which must also appear in the sample. That is, divide the wider population into mutually exclusive homogeneous groups. Stage number 2, randomly sample within these groups, the size of each group being determined by judgment or tables of sample size. A stratified sampling or a stratified random sample is a useful blend of randomization and categorization, therefore enabling both a quantitative and qualitative piece of research to be taken. In simple words, it is a suitable sample both for qualitative and quantitative type of research. A quantitative piece of research will be able to use analytical and inferential statistics, while a qualitative piece of research will be able to target those groups in institutions or clusters of participants who will be able to be approached to participate in the research. The next one is a cluster sampling. Well, when the population is large and widely dispersed, gathering a simple random sample poses administrative problems. Suppose we want to survey students' fitness levels in a particularly large community or across a country. It would be completely impractical to select students randomly and spend an inordinate amount of time traveling about in order to test them. By clustering sampling, the researcher can select a specific number of schools and test all students in those selected schools. That is, a geographically close cluster is sampled. In an example, now diagrammatically, you can look at the one cluster sample geographically, and one cluster you take, and that would be representative. So sampling within a particular cluster, for example, geographical cluster, or it is useful where population is large and widely dispersed, and to reach them is a huge problem. It's not manageable. So you can work on the clusters. So one would have to be careful to ensure that cluster sampling does not build in bias. For example, let's imagine that we take a cluster sample of a city in an area of heavy industry or great poverty. This may not represent all kinds of cities or socio-economic groups. That is, there may be similarities within the sample that do not catch the variability of the wider population. The issue here is one of representativeness. Hence, it might be safer to take several clusters and to sample lightly within each cluster, rather to take fewer clusters and sample heavily within each. So cluster samples are widely used, especially in small-scale research. In a cluster sample, the parameters of the wider population are often drawn very sharply. A researcher, therefore, would have to comment on the generalizability of the findings. The researcher may also need to stratify within this cluster sample if useful data, that is, those which are focused and which demonstrate discriminality, are to be acquired. The next kind of sampling used in research is called stage sampling. Stage sampling is an extension of a cluster sampling. It involves selecting the sample in stages, that is, taking samples from samples. Using the large community example in cluster sampling, one type of stage sampling might be to select a number of schools at random, and from within each of these schools select a number of classes at random, and from within those classes select a number of students. Morrison, in his work 1993, provides an example of how to address stage sampling in practice. Let's say that a researcher wants to administer a questionnaire to all 16-year-old pupils in each of 11 secondary schools in one region. By contacting the 11 schools, she finds that there are 2,000 16-year-olds enrolled. Because of questions of confidentiality, she is unable to find out the names of all students. So it is impossible to draw their names out of a container to achieve randomness. And even if she had the names, it would be a mind-numbing activity to write out 2,000 names to draw out of a container. So she finds that for a random sample of the 2,000 students, the sample size is 322 students. How can she proceed? Well, the first stage is to list the 11 schools on a piece of paper, and then to write the names of the 11 schools onto small cards and place each card in a container. She draws out the first name of the school, puts a tally mark by the appropriate school on her list, and returns the card to the container. The process is repeated 321 times, bringing the total to 322. The final totals might appear thus. The schools 1, 2, 3, 4 up to 11, and total required number of students from each school. School number 1, 22, number 2, 31, 3, 32, 4, 24, 5, 29, 6, 20, 7, 35, 8, 28, 9, 32, 10, 38, 11, 31, and total would be 322. For the second stage, the researcher then approaches the 11 schools and asks each of them to select randomly the required number of students for each school. Randomness has been maintained in 2 stages, and a large number, 2,000, has been rendered manageable. The process of work here is to go from the general to the specific, the wide to the focused, the large to the small. So caution has to be exercised here, as the assumption is that the schools are the same size and are large. That may not be the case in practice, in which case this strategy may be inadvisable. So that was about different types of sampling. Well, there are more types of sampling, and maybe we'll discuss in our next session some of those remaining types of sampling, and then we'll close with some other factors related with sampling, choosing the appropriate sample and choosing the representative sample, because it is one of the fundamental aspects of research. So thank you very much for listening. That is the end of this session.